Okay, so in this one, x is going to infinity, means like it's kind of like x is going over there. So if the graph goes like that, right, what happens to the y as x goes towards infinity? So one thing that can help simplify these when x goes to positive or negative infinity is if you're doing a rational function, which is like the ratio of polynomials, then only the highest power term will matter. Okay, what's the highest power term in the denominator? This is the highest power term, right? And in the numerator, what is the highest power term? Negative 3x cubed. This is the one with the highest power. When x goes to infinity, positive or negative, then this and this are the only thing that will matter if it is a ratio of polynomials. That's something you should use, but I'll show you why that is the case, right? But once you understand why, then you can use that idea that, okay, only the highest power terms will matter. So when x is going to infinity or negative infinity, what we want to do is get the all the x's wherever they are appearing, move them into denominators. How can we do that? So highest power is 3 and here is the highest power 3, right? So whichever is the highest of all of these, first of all, we might want to rewrite it as, so right now what I'm showing you is the general technique of how to deal with x goes to infinity or negative infinity. And then you can simplify based on what you learn. Now the biggest power in all of these terms is 3, right? So I'll divide both of these, numerator and denominator, by x cubed. I can do that, right? I'm doing the same thing to numerator and denominator. So then the fraction remains the same. So this becomes negative 3x cubed over x cubed plus 2x squared over x cubed plus x over x cubed. And here x cubed over x cubed plus 5x squared over x cubed minus 7 over. I'm just manipulating to bring it to a form which will be easy for us to use. I just divided the numerator and denominator by the same thing, which is the x to the power, whichever is the highest power in all the terms. So now this x cubed cancels out, 1 over x, right? So, and this is 1 over x squared, right? And then this is also 1 over x, and this is that, it's already there. Remember, x was going to infinity, means x is becoming very big. And all the x's that we have are now in the denominator. So what I have is negative 3 plus 2 over x plus 1 over x squared over, this is 1 plus 5 over x minus 7 over x cubed. Now you see x's are only in denominators. So what happens when x is in denominator and x becomes very large? So if I have some number, let's say 5 over x, and this x is becoming very large, what is happening to the whole thing? If x keeps becoming bigger, what is happening to 5 over x? If x keeps on growing, this whole thing will become closer and closer to 0, right? If you just have x or x squared or x cubed only in the denominator, and x is going to infinity or negative infinity, that whole term will become 0, right? Because this will keep on growing, million, billion, trillion, gazillion, it will just keep growing. The denominator, numerator will remain fixed. So this whole thing will become 0 in the limit. That means this 2 over x will become 0, 1 over x squared will become 0, 5 over x will become 0, 7 over x cubed will also become 0. So this was still, all of this was, the limit was still there here. Okay. If all of these will become 0, then what is left? Negative 3 over 1. So that's the limit. Now, if you notice, right, by what we are doing, only the biggest power term is making a difference because the lower terms become 0 when x is going to infinity. Same will happen for negative infinity. So what we could have done with that knowledge, we could have straight away, when we looked at this, when we look at this problem and we see, oh, x is going to infinity, so only this term will matter and that term will matter. So it is going to become negative 3x cubed over x cubed. These other terms will not matter. And this I can cancel. So the limit is negative 3. See how easy that is? But you should do that once you understand why it works like that, right? Otherwise, you'll have one more thing to memorize. And if you forget, then you will not know what to do. But now that we know when x is going to infinity or negative infinity, we can reorganize them like this, and then everything other than the highest power term will become 0. So we can just ignore these lower power terms, and just write out the highest power term, and that will give me the limit. And what can happen? There are 3 scenarios that can happen, right? When you're finding limits as x goes to infinity or x goes to negative infinity, and we have a rational function, right? So you may get, if you are looking only at the highest power term, right, you may get something like, okay, 2x cubed over 3x cubed, right? Something like that. Or you may get, okay, 5x squared over 3x cubed, right? Or you may get 7x4 over 3x cubed, right? It could be anything like that, correct? This will cancel out. So 2 over 3. And here, 1x will remain in the denominator. What's the limit here? If you divide a finite amount in infinite parts, one part is becoming extremely small. It is going towards 0. So the limit is 0. And this one, this is 7x over 3. As x goes to infinity, what will happen to 7x over 3? 7/3 of infinity is infinity, right? But what happens if x is going to negative infinity? In the first case, it went to positive infinity. In the other case, it's going to negative infinity. If x was going to infinity, it goes to infinity. If x is going to negative infinity, it's going to negative. If you have this, it's indeterminate, or this, right? Or this. Anything times infinity is infinity, but anything times 0 is 0. So 0 times infinity is indeterminate. We don't know whether it should be 0 or infinity or something else. It could be anything. Similarly for 0 over 0 or infinity over infinity. So for these kind of indeterminate forms, we have to do something else. But otherwise, a finite number times infinity is infinity. Finite number divided by infinity is 0. Positive, negative, just deal with it separately. Don't get confused by that. And then we'll learn another thing later where all of these indeterminate forms, if we run into any of these indeterminate forms, there is a way to find that limit. So that you'll learn later.